And it's a multiple choice that came from an old exam somewhere. Which indicator would be the most suitable to show the equivalence point of this titration curve? Well, first of all, where do we find the equivalence point on a titration curve? In the middle of the steep curve. Somewhere around 8 or 9. Right? So now you look at these options now, and you want to find out which of those change somewhere where 8 is in the middle. And Congo red is not on your chart. This must be an old exam. It is. Oh, that was when I added to the end. It's 3 to 5. Chlorophenol red is 5.2 to 6.8. Thymol blue is either 1.2 to 2.8. Well, we know that's definitely not it. But 8 to 9.6. And 1, 2, 3 trinitrobenzene is 12 to 14. So which is the right answer? Thymol blue. Thymol blue changes around the spot where we want. Because remember, the end point is where the indicator changes color. We pick that to correspond to our equivalence point. Okay, they're not always the same, but we pick the end point, or we pick the indicator to change color at our equivalence point. So it's kind of, they often ask that in terms of, do you understand the difference between the two terms? Okay, so just to make sure that you know the difference between some of the terms involving actual titration, titration is the progressive addition of one reagent to another. That is a titration, and you always do it if you know the concentration of one thing, you're trying to find the concentration of the other. Acid-base chemistry, the reagents are aqueous solutions, one of which is a strong acid or strong base. So you're always reacting it, typically with hydronium or hydroxide. Typical titration involves progressively adding a solution of known concentration. So typically, whatever's in your burette is what you know the concentration of, and you're adding it to your sample that you're trying to find the concentration of. So when we did vinegar with our sodium hydroxide, we knew the sodium hydroxide. We were trying to find the concentration of our sample, which was the vinegar. The amount of titrant added is just enough to completely neutralize. Indicators added to detect the equivalence point, but they're not the same. Again, the equivalence point, chemically equivalent amounts of titrant and sample have been reacted. The endpoint is where the indicator changes color. Okay, so this is a question that came from, I believe, an old exam as well. pH test of water in a holding pond at potash production plant. Build alkaline conditions. 500 milliliter water samples from the pond. Okay, so that's our key thing. We're titrated with standardized 0.221 mole per liter hydrochloric acid. Pardon? Standardized means you know the exact concentration of it. Okay, let's complete the table by calculating the missing values. Calculate the average volume of HCl. So what we do, we subtract 50, take away 44.76. Okay, so we just subtract to get the final values. Now we want to look at the numbers, and remember, you want your final volumes to be within 0.1 mils of each other. So we lose trial 1. The difference between this one and this one is 0.13. Difference between here and here is only 0.03. Right? So those are very close. So now we find the average between those two. That's an 8. Yeah, you'd be wrong. No, they're not. It's 0.13. It's 5.10 or 5.095. Yeah, we'll say 0.95 milliliters. Evaluate a chemical equation for the reaction between hydrochloric acid and potassium hydroxide. So that's what we were. So it's KOH plus HCl. Finding the average of these two. 5.095. Okay, so KOH plus HCl, the reaction is just double replacement. So it's KCl plus HOH. Okay, so the equations for these are, again, double replacement. So whatever's in front here, change a spot with the one in the front. You would be expected to be able to do neutralization reactions. Okay? Oh, now on your exam, it would tell you it's a reaction between hydrochloric acid. Your exam would tell you these formulas. Potassium hydroxide is KOH. Okay, that would be told to you. Yeah, probably. So now it says calculate the hydroxide ion concentration and the pH of the pond water. So, well, we're going to find out first the concentration of KOH. You could also do these using Bronsted-Lowry reactions. This would just be OH plus hydronium. Okay, either way you do this, you'd be right. So HCl, we knew the concentration was 0.0221. 0.0221 mole per liter, and that value is C. We knew that our volume of our titrant, which was HCl because that's what we added, so our volume was 0.00509.5 liters. We're looking for the concentration of this one. And we know the volume here was 0.5 liters. That's okay. So the first thing we do is we have to find the moles of the substance that we know enough information on. So we find number of moles of HCl. The hardest part here is remembering how to rearrange the formula. So number of moles is C times V. I'm going to run out of room, so I'm not going to put in all the values. These are the two values that we're using. It comes out to be 0.0001126 moles. Most of these questions you will do will be situations where it's a 1-to-1 mole ratio. Doesn't always have to be, so make sure you check. In this case, the mole ratio is 1-to-1, so the moles of KOH is the same as the moles of HCl. So number of moles here is the same thing, 0.0001126. Now I know the number of moles and I know the volume, so I can find the concentration. C equals N over V divided by 0.5, 0.002. Oh, sorry, 0.000 225. Note to self, make sure to leave more room. Mole per liter. Now, that is the key thing here. Most of the time when you do these questions, you're only being asked to find the concentration. This question, they said find the pH. Well, KOH is what we found the concentration of. KOH, is that a strong base or is it a weak base? It is strong, so we can find directly what? POH. POH is negative log concentration of hydroxide. Plug in that number. Log comes out to be 3.647. So pH 14, take away 3.647. So long question, no doubt. Comes out to be 10.35.